Good morning. All right, so there's a reason why I'm doing a video today, and it's because we're fixing to start chapter 19, and we're going over angles, which means I'm going to have to show you how to use a protractor. So you may already know how, but we're going to go over it anyway, just to make sure. So make sure you have one. They're cheap. You get them at Dollar General, I think, or Family Dollar, Walmart, whatever. Mine's been used quite a bit. In fact, it's all scratched up and kind of broken and such, but it still does the trick. But you can get a fancy one or you can get a cheap one, but the cheap ones work just as fine for what we need it for. So anyway, make sure you have a protractor because you're going to need it by, I do believe, tomorrow. Yes. Anyway, so here's the funny part. So I was thinking, well, how am I going to show them how to use a protractor when I don't know how to do it with my camera. So my camera right here, I can move it around, but I can't hold it up with one hand and then use another hand to show you how to do it, because then I jiggle and wiggle and then you'll probably throw up because you'll be sick at your stomach. So I've decided to come up with an invention to be able to hold my camera up so that I'll be able to show you how to do the protractor without me having to hold the camera. So what I'm going to do, I have two of these. They're two paper towel holders. See the little loopy-doopy thingy at the top? All right, so I've got those, so I'm going to use those. And then I found this perfectly good round stick. And so I'm going to put it in here. I've already tried this and it works. It's my super duper invention. So I put this, well, I'll have to do this way. Let me back up. See this? And so then I set it on my desk. I'll have to move the paper towels. And then I'll be able to put my camera on it, and it'll be pointing down onto my desk so that I'll be able to show you how to do a protractor. So that is what you call, I don't know what you call it, but that's pretty good, I thought. Anyway, let's go ahead and get started with chapter 19, talking about angles. I love angles. I like geometry in general. I just do. I think it makes such good sense. I'm not real good at it, but I like to study it. And I love angles because they're so perfect. And I love studying them because they're easy. So anyway, let's get started. And this section, actually 19.1 is very easy. It's just kind of going over measuring angles and how they work. Okay, move on from measuring shapes to exploring them in more depth. We'll start our next level of investigations by taking a look at an important part of many shapes, which are the angles. Remember, an angle is a fancy name in Euclidean geometry for the intersection of two straight lines. We call the point at which the lines intersect the vertex of the angle. There's your little triangle there. You see where two of them come together. That's the vertex. That's an angle. And there's three of them there. They just showed you one. Up until now, we've used terms such as right, obtuse, and acute to describe the size of angles. Remember, acute angle, oh, it's so cute. It's less than 90. A right angle is 90 degrees, and an obtuse angle is larger than 90 degrees. So one method for measuring angles is to describe the angle's location on a circle. This is where it gets interesting. It brings in a little bit of history. This method breaks a circle into 360 small increments called degrees. The symbol to represent degrees is, of course, the little small circle next to the number like 90 degrees. All right, let's look at the next page. You see that circle at the top, and you see all those lines. Look at those degrees. You've got 0 out on the side where 3 o'clock would be if it were a clock. 0 degrees or 360 degrees. Okay? Then each one of those lines is a degree all the way to 270, and then from 270 to 180 and 180 to 90. 90 all the way down to either 0 or 360. Now, to measure an angle, we measure how many of the small increments, those little tiny ones in there, what we call degrees, the angle spans. The angle shown up here at the top, you see that angle, it's got the little line on it right there. that is 45 degrees. So it has a measurement of 45 degrees. Now, let's talk about the word degree. The word degree comes from the Latin de or da, meaning down, and gradus, meaning step or grade. You can think of degrees as little steps making up a circle. We could have chosen any number of these little steps or degrees to fit within the circle. In fact, rather than using 360 degrees, we'll sometimes think of the circle as consisting of 400 units called gradians, or in the case of a clock, as consisting of 60 minutes. But however we choose to break up a circle, we need to be consistent. It wouldn't help us to communicate if I broke a circle into 70 parts and you broke it into 360 parts. So when working with degrees, we break the circle into 360. Why 360? Perhaps 360 has remained the standard throughout the centuries because 360 has so many factors, making it easy to subdivide and work with. No one knows for sure why 360 was originally chosen to use in subdividing a circle. The Babylonian number system, which was based on 60, which is a factor of 360, or calendar, which was 360 days long, might have had something to do with it, although according to one source, we don't find any evidence that the Babylonians themselves divided a circle by 360. So we don't know. We do know, though, that 360 was utilized extensively by the Greeks to break down circles. The Greek mathematician Ptolemy, in his work, Syntaxis, broke each degree further down into 60 parts, or minutes, and each of those into another 60 parts, or seconds. All right, you ever heard of someone talking about making a 360, or someone made a 180? Well, making a 360 degree turn makes you go back to 0, while turning 180 puts you facing the opposite direction. So when you make a 360, you come back to your original position or viewpoint. When you make a 180, you change your position or viewpoint and you go the opposite direction. So a 360 is just making a full circle. A 180 is making a half circle. All right, now let's go down to the mechanics of it. Now we use this device called a protractor to measure the degrees of angles. Protractor has half of a circle with the degrees marked on it. You can't really see mine. My numbers are kind of messed up, but you can kind of see it a little bit. But we've used this for quite a while. I think it was actually my sister's. Now to use a protractor, basically you place the center of the bottom of the arc at the place where the two lines meet, or the vertex, with one line matching the straight edge. Then look to see at what degree the other line intersects the arc. So basically, now I'm just going to read through this. When we get to our page, I'm actually going to kind of show you how to do it, I think. On our page, I'm just going to kind of show you how to measure it. Tomorrow, in the next lesson is really the one that we're going to have to use it a little bit more for. All right, and you can see that picture. They drew a very good picture as to how to measure it. So that one goes to 60. Note that the protractor has two different zeros. Notice that on each side. Okay? One on the left and one on the right. The far one on the right is either 0, 180, or the other one that was on the left. The one on the right is either 180 or 0. This allows us to start our measurement from either direction. We just have to be careful to read from the same scale as the 0 that we're starting from. So that means if you're starting from the left side, you're going to the left side like in that first picture. That means you're using the numbers on the top where the 0's at. If you're going on the other side, then you're using the zeros, the numbers on the bottom where the 0's on the bottom. It'll make a little bit more sense when we do it. So if you'll look at the last one, see they measured this one on the other side, but it still measures 60 degrees. It just depends on, you might look at it and go, oh no, that's 110 degrees. No, it's not, because they started from the right side, so they have to use the number on the bottom, because you always have to start on the side. You always have to start on either side, but you have to go where there's a 0. You have to use the numbers either on the top or the bottom, whichever one the 0's at. I think I just kind of messed that up for you. All right, if you need to, this is on the back, on the next page, 360. If you need to, you can always extend a line so it reaches the protractor, because sometimes the lines are really short and it's kind of hard to see. You can do that. Okay, so in your work text, let's take a look at worksheet 19.1. So on number 1, A, B, C, and D, we're just going to be using a protractor to measure, which means I'm going to have to set up my gadget. It requires some. I told you it was going to work. Okay, so what we're going to do on this page, I have to blow that stick got a lot of stuff. Okay, so I don't have a pencil close by, but when you've got measurements inside of a book and you need to use your protractor, it's a little bit odd because of this, where the book comes right here, and you can't get now these two you probably could do, and even this one you might, but when it's close to over here by the side of the book, it's really hard to do that. So I remember when I was in school, my teacher showed me how to use a piece of paper and trace lightly the lines. Okay, and then this is where that was. Okay, so that's A. I'm going to go ahead and try B, see if I can, it's up here. I'm trying to see this. I think a piece of notebook paper might be a little thinner so you can see through it a little bit better. And then C, oh goodness, it's very light. I can barely see C. I would need some notebook paper, I do believe. I think I can't see C. Now I can see D. It's like that. Okay, so I won't be able to do that. Okay, so now what I'm going to have to do is turn this off so I can reorganize. Okay, so here are my lines that I drew. I just traced them. Like I said, I think it'll do better if you use a piece of notebook paper. But I couldn't see C because it was a little bit light, too light. So we're going to look at A. So basically the way that you're going to do this, because the instruction says to measure the marked angles in these pictures with a protractor, round your answer to the nearest multiple of 5. Example, 43 degrees would round to 45 degrees. Okay, so the way you do it is you're going to take your protractor, you see this little hole right here, and you see these lines that line up with the hole. All right, what you do is you put this hole on the vertex. Let me move this over. All right, so you put the hole right straight on the vertex. You have to really look straight down at it if possible. Sometimes you have to stand up. Then your line right here, you want that line to be exact on line with this. Okay? Now what we're going to do, we really should use a piece of paper, and I don't know, I think I might have one right here. Let's see. All right. The best way to do it is to line another piece of paper up with this one, if it doesn't go all the way up, and see what it lands on. Well, you can obviously see what number this is. It's backwards. I have my protractor backwards, but you see what number it is. It's 90 degrees. Of course, you can look at that and tell it's 90 degrees, but just to show you, that's what it was. So that is a 90-degree angle. Okay, now on B. Now, notice this right here. This means this is the angle they want you to measure. This over here is actually an angle. It doesn't look like it, but it is. Now, we'll talk about how to measure these types of angles tomorrow or the next day. I can't remember. So the angle inside here is the one they want us to measure. So I'm going to turn it upside down so I can more easily get to it. Remember, I'm going to turn my protractor around. Now it's on the right side. This sure gives me a small space. All right, so we're going to put our circle on the vertex. And then we're going to line up this line here as straight as we can on that. All right, then we're going to use our piece of paper. I'm going to move to kind of line that angle perfectly and see what it lands on. Okay, so now since we're on this side, notice there's two numbers here. Which one are we going to use? The bottom number, because we're on the right hand side, which means we start here. This would be 0. So we're starting here. We're going to use these numbers. We don't use this one. So if this is 40 and this is 30, that means this would be approximately 45 degrees. So B would be approximately 45. Now I'm not going to do C. I'd have to use my book. I'm going to let you do C, but I will do D with you. So let us get the protractor. Let us see what we can do here. Okay. That's not a perfectly straight line. Okay. Notice how I've got my circle right here on the vertex. And then this line here is straight along with this line. So this is, and now, okay, it's perfectly good. Now, notice again, there's two numbers here. Are we going to use the ones on the bottom or the ones on the top? We're using the ones on the top because we start with a 0, whichever side it's on. So we do the numbers on the top. So this is going to be about 60. Looks like maybe about 63 degrees. Because there's 60. Whoops, I'm out of the. There we go. That's 60. So it looks like it's on about 63. So we'll round that to the nearest 5, which would be 65. So D would be approximately 65 degrees. Okay? I can't get to C unless I use my book, and then I'm going to have to turn it off again and readjust, but I'm not going to do that. All right, so you'll have to do C. Now the rest of the page, the rest of the bottom and the back, looks like it is skill sharpening. It should be everything you've done. So you got some conversions in there, so make sure you do those well. If you need any help on the rest of the page, let me know. Otherwise, that will be all for